Okay, next first one, we cover statistical inferences. I think in my post notes, I already covered a little bit, but I'm going to give you what? An overall review here. What's statistical inferences? It's use sample data to infer population parameter. Let's look at this example. A coin is flipped 100 times. And we observed 40 heads. And the question is, based on above what? Based on above information, is the given coin fair? It's a fair coin or not a fair coin? Okay? So this is our question. Okay? What is a fair coin? Say pi is a probability of getting heads. Where is 50%? Probability of getting heads is 50%. That means we have 50% chance to get a head. We also have a 50% chance to get a tail. 50-50. Okay, so it's a fair coin. Now, what do we have? We have sample percentage of getting heads. Sample percentage of getting heads is X bar. Okay? It's sample total divided by sample size. We flip the coin 100 times, we see 40 heads out of 100. So sample percentage is 40%. And this is sample percentage. This sample percentage is what? This is called statistic. Okay? And we use statistic to estimate pi. Pi is the true population percentage of what? Of getting heads. And this pi here is called population parameter. We use a sample statistic to estimate population parameter. This procedure is called statistical inferences. Okay? And three common ways of doing what? Statistical inferences. There are A, point estimation. B, interval estimation. And C, hypothesis testing. There are three common ways to do statistical inference. We're going to introduce you these first two very briefly, because this is something if you read the YouTube video, you know what it is already. My today's main effort to introduce you how to do what? Hypothesis testing. Okay? Let's take a break here for like what? 1 minute. Okay? Go over the material I just covered. And today's lecture is recorded, okay? And I will post online later. Let's take a short break, 1 minute, and you read over what I just covered, okay? Okay, let's proceed, okay? Let's proceed to the next page. Now, first one, let's talk about what's point estimation. We're going to use the same example. A coin flip 100 times and we see 40 heads, okay? Now, this is from 0, this is 1. Pi is the unknown population parameter. Pi is unknown population parameter we want to estimate, okay? And our estimator is what? Is X bar, okay? This is sample percentage. We use sample percentage, try to estimate what? This is a population percentage. And the observed sample percentage. The observed sample percentage is 40 out of 100. In 100 flip, we see 40 heads. So this is what? This is 40%. And we use 40% to estimate pi. A failed coin means pi should be equal to what? 50. But now we only see 40. So based on point estimation, 40% is not equal to what? 50%. 50% is what you expect to see on what? On a failed coin. So you say the coin is not a failed coin. Okay, but this is a not very ideal approach. Okay, because even this is a failed coin, you flip 100 times, you probably don't get exactly what? You probably don't get exactly 50. Okay, so point estimation is what? Is not a very good approach. Requires some improvements. And as in my video, I say interval estimation can improve that. Okay, so let's see what's interval estimation. Interval estimation, you don't use point to estimate another point. Interval estimation, you use interval. You try to construct interval. You try to construct a narrow interval to catch the location of what? The location of pi. So instead use the point, instead of use the point to catch another point, interval estimation is like this. Here is 0, this is 1, this is unknown population parameter. Okay? Say this is your x bar. Based on here, you create a narrow interval. Here is x bar minus h. Here is x bar plus h. Okay? You try to construct a narrow interval to catch the location of pi with a big probability. How big is it? Usually 90% chance, 95% chance, or 99% chance. Okay? So look at here. The interval we constructed is called x bar minus h to x bar plus h. You try to construct this interval. Say you try to construct this interval to catch pi with what? Say 95% chance. You try to construct the narrow interval to catch the location of pi with a big probability, okay? And as you can see in the YouTube video, okay? X bar plus or minus h. What's h? H is called margin of error. H is called margin of error, okay? Now, from the YouTube video, you see the derivation goes this way. X bar plus or minus Z star. Z star is called critical Z value. And times what? Square root of variance X bar, okay? Or our textbook call this is what? SE X bar, okay? Remember, this is a notes I post online, SE X bar, right? So, let's go further. What's X bar? X bar is 40%, but let's keep here. Do you still remember what's SE X bar? Recall from the variability of average and proportion. SE X bar is equal to SE what? total. This is SE total over N. And this is SE total over N. Okay? SE total is what? Standard deviation of the box times what? Times square root N number of draws, and then divided by draw, divided by N. Okay? And this is when the draw are made what? With replacement. Remember, this is a box model. When you see a head, you count as a head, one head. When you see a tail, you count as 0 head. So this is what? This is pi, and this is 1 minus pi. But you don't know what's pi. And draw here is with replacement. Since this is with replacement, you don't need to worry about continuity correction. Okay? So this term is just become standard deviation of the box divided by, look at here, N can be written as square root N times square root N, up to cancel one of it. We have standard deviation of the box divided by square root of N. Okay? Let me stop here. And let's have what? 1 minute break, okay?
Hi, Scott.
Yes?
I just joined the meeting. So
Okay.
are we going to have the meeting like every Monday or?
We're going to have meeting tomorrow. Make sure you don't miss the meeting tomorrow.
Okay.
Tomorrow, I'm going to cover a second example on hypothesis testing. Okay?
Okay.
We're going to have a meeting today. We're going to have a meeting tomorrow. We're going to have a meeting on Wednesday, and that's it. Okay?
The same time? Like,
No. Tomorrow will be what? Tomorrow will be, let's see, what time tomorrow? Tomorrow will be 5:35.
Okay. What about Wednesday?
Wednesday will be just like today.
What we start like what time we started today? Cause I just finished my other online class.
Well, the YouTube video will be recorded and posted online.
Oh, okay. Thank you.
Yep. But wait a minute. How come you're in a class? This is supposed my time.
No, today's
Monday, right? And Monday, this is
class on Tuesday and Thursday, but I just received the
email.
Yeah,
that's fine. That's fine. If you come from class B, that's fine. That's no problem. Okay. That's no problem.
Okay.
Yeah.
Okay.
But you need to attend my class tomorrow, right? Because that's your.
Yeah.
But this time is open. Now it's open for both what? 101A and 101B. Okay?
Oh.
I'm going to meet today, tomorrow, and Wednesday, 3 days. Okay? We're going to cover different topic, and every time we cover, the material will be recorded and posted online. Okay?
Okay.
Yeah.
Excuse me, sir. May I take a look at the context of the previous paper?
What's a previous paper?
Yes, previous paper.
Yeah, this one, right? Okay.
Yes.
Now you need to patient, right? Some people probably not copy that fast. I suggest you take a picture, right? Use your cell phone, take a picture, okay?
Okay. Also, wait a moment. We need to take a picture. I'm sorry. Tomorrow, we have the meeting.
Yeah, we have meeting tomorrow, but tomorrow meeting begin at 5:35 to 7:35. No.
Okay.
No, sorry.
Also, with time?
Tomorrow meeting is from 4 to what? Tomorrow's meeting is from 4 to 5:30. And the Wednesday meeting is beginning from what? Wednesday meeting is beginning from the let's see. Wednesday meeting is is begin from just like today, right? 12:45. Okay.
Okay. Okay.
So this week we're going to offer three what? Three online section. Okay.
Okay.
What about our quiz 2 and the final?
You come late. That's why you did not hear. Okay. The oral quiz, no, there will be no quiz. Okay. The one I'm going to give you is called final assessment.
Oh, okay.
The final assessment. It's only come towards 15%. Okay. And the detail, I will send everybody an email. No, or I post one on my Google website and C4. You can read those documents. Okay.
Okay, thank you.
It's too time consuming. Answer your question offline. If you have a copy, you still have what? You still have 30 seconds. Then I'm going to move to the next topic. Okay.
Hi, Scott.
Mm-hmm.
Did you mention exam syllabus yet or no?
Say that again.
So did you mention exam syllabus? Is it cover all the chapters?
There will be a document on the final assessment. I will post it tonight. You can take a look. Okay.
Oh, okay.
Don't ask me this question online because it's recording, right?
Sure. That's
Thank
why I
you.
just message you. Thank you.
If you want to ask me any question after the whole section is over, you ask me after what? After section is over. How about that?
Yeah, okay, sure. Thank you.
Yeah. Thank you. Okay, let's move on. Now, this is X bar plus or minus Z star. Z star is the critical Z value, standard deviation box over what? Square root n. So I just copied down what I wrote on the previous page. X bar plus or minus Z star times what? SE X bar. This is called H. H is the margin of error. Okay, as I showed you earlier, this one can simplify to x bar plus or minus z star. Standard deviation of the box divided by square root of n. N is the sample size. And remember, what kind of box is this? This is a count box. Am I correct? This is a count box. And we make n row with replacement. Okay, we make n row with replacement. So, I think I covered this one in my posting notes. Okay, if a box has only two different numbers, what is the standard deviation of the box? It's what? The large number subtracted by the small number. And then square root of the proportion of the large number times the proportion of the small number. Okay? This is a formula I posted notes online. Okay? So we're going to use that. But do we know pi? We don't know pi, right? We don't know pi. So when we don't know pi, what can we do? We estimate pi by what? By sample percentage. And the sample percentage in our example is 40%, okay? So this becomes 40% plus or minus z star. And this one become 40% times 60% divided by 100, okay? Divided by 100. So after simplification, this is what? 40% plus or minus z star. And this number is very close to what? 1 over 20, which is 5%, okay? Very close to that. So in this case, the only job left undone is that we need to find what the z star, right? From standard normal table. From YouTube video, go back to read the YouTube video, okay? If this is z, I want to construct 95% confidence interval. The middle 95%. When you check table, what do you find? You still remember what I covered on YouTube video about this part? Anybody still remember?
1.95.
Yep, very good. That's one I want to hear. 1.95, okay? Very good. And I also show you in the book, okay? And also show you in the book. Please look at this is our book, okay? This is our book. 1.95, do you read that? 1.95, okay? You move horizontally, what do you find? You find this is what? 94.88%, very close to 95%. So the corresponding z value is what? 1.95, okay? So we put 1.95 here, and normal is symmetric. This is minus 1.95. Okay, so this is roughly what? Equal to 2.5%. This is roughly equal to what? 2.5%. So you plug in 1.95 here. So what do you get? You plug in the number, you get the interval is what? 0.304 to 0.5. 496 is a 95% confidence interval for what? For pi. Okay? It's a 95% confidence interval for pi. But the above interval does not cover pi equal to 1/2, or you say 50%. When pi equal to 50%, that's how we call a coin is a failed coin. But this interval doesn't cover 0.5, or you say 50%. So based on the collected data, the coin is what? Is a bias coin, okay? Because this interval does not cover what? 50%, okay? This is called interval estimation, okay? I'm gonna stop here for 2 minutes, okay? Think about this.